All right, so I think one aspect that is very important is to understand how to convert a differential equation to a system of first order linear differential equations, because that's going to appear later on in the modeling of the spring system. So it's a good idea to start with a simpler case. So let's see, if we have this equation over here, the first thing I would do is I would write it as in standard form. So first thing, write in standard form. So how would we do that? Well, that would just require us to take this differential equation and write negative 4y plus t times the cosine of t. I just subtracted negative 4y from both sides. Well, now we can do something else. Well, first of all, let's say that there is a y prime here that we just don't see. So because I like to keep my things neat, I would write 0y prime right here. So the first thing that I would do is I would say that y is equal to x sub 1, and that y prime is equal to x sub 2, and that's it. Now, I would take the derivative of these. So if I take the derivative of this, I would get y prime is equal to x1 prime. But remember that y prime is also equal to x2. So I can write it like this. Now if I take the derivative of this, I would get y double prime is equal to x sub 2 prime. But that's also equal to this right here. Look, we have y double prime is equal to this whole business. So, and let's substitute that y with our substitutions our definitions that we made there. So let's say that 0y, this is going to be 0, what's y prime? X sub 2 minus 4 times y, which is x sub 1. And then we have plus t times the cosine of t. Well, now that we have this, what do? Well, we look at the equations that have the same variable and their derivative, and we try to create a system. So in this case, we have x1 and x2 as the variables. So we need two equations, and indeed we do have those. So we can rewrite this as x sub 1 prime equals to 0 x sub 1 plus 1 x sub 2 plus, that's it. And then I'm looking at the second equation now, x sub 2 prime. That's going to be equal to, well, we do have an x sub 1, so we'll put that in the front so that we line all of our terms, and this is crucial to pick out the coefficient matrix. Then we have 0x2 plus t times the cosine of t. So let's put a 0 up top right here. Now we can convert it into matrix form. I'll write this as a matrix. This is my derivative of my original vector. And then I can pick out the coefficient matrix. It's just going to be 0, 1, negative 4, and 0. And then from that, I'm going to have my x sub 1 and x sub 2 here. Plus, what am I going to add? I'm going to have the vector for the forcing function, t times the cosine of t. And there you have it. Now you could say that this is k prime. Well, let's not call it k, let's call it x prime, that this is my matrix A. You can say that this is my X, if that was X prime. And you can call this f of t. So now you can rewrite this as the vector x prime is equal to A times the vector x plus f of t. And you would notice that this is a non-homogeneous first-order linear system because it has that forcing function. Well, I hope this was useful, and I'll see you for another exercise.